Hi Algebra 1 class, welcome to your first video lesson for Algebra 1. Today I'm just going to do a short video on just a couple different problems that you're going to run into in your homework for Lesson 5. And I want to run over how I want you to display your work in your homework when you turn it in. So let's just get started. The first thing you're going to run into, the first problem I think it is what are natural numbers? And you need to write down the natural numbers. There's different categories of numbers. There's natural numbers, whole numbers, integers. We'll get into real numbers, irrational numbers, rational numbers, and imaginary numbers later on. But for this lesson, they just want you to know the difference between natural numbers, whole numbers, and integers. So let's start out with natural numbers. Typically, when you hear of natural numbers, it's the same thing as counting numbers. So, if you know what counting numbers, they're the same as natural numbers. These are the same as counting numbers. And so you think, what are counting numbers? Well, counting numbers are the numbers that you use to count things. So when you think of natural numbers, it's just going to be a set. This indicates, these braces indicate a set. So the counting numbers are the set of numbers you would count with, like 1, 2, 3, and you can just put, as long as you put 3, you're usually in good shape. And after you put some numbers, you just put dot, 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 and it means that this pattern is going to continue. So that is a set of counting numbers, the numbers you'd use to count something. You wouldn't use 0 to count something. You'd say, oh, if there's counting that, that's 0. So counting numbers are actual numbers that you count. There's no fractions, you'll notice. It's just counting objects. Whole numbers, on the other hand, they often say for whole numbers you want to start with 0 because there's a 0 in whole numbers. Actually it's an O, but we can use that. And whole numbers start with 0. So whole numbers start with 0. They're whole numbers, that means they're not fraction, and they're positive numbers. They're not negative. So our whole numbers, if you were writing down the set, would be 0, 1, 2, 3, 4, etc. And you just put your dots and close your braces. Those are whole numbers. They start with 0. And then the final one we're going to cover are integers. Integers are just positive and negative whole numbers. So if we're going to write down our integers, we're going to have negative numbers. So I'm going to start with the dot, dot, dot because it's going to continue in both directions. So you can start wherever you want. I'm going to start with -3, -2, -1, 0, 1, 2, 3. Dot, 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 because they go on and on and on forever in both ends. You notice the integers are not fractions. Those would be rational numbers, which we'll get to in another lesson. So those are the three types of numbers we're going to be working with. Natural numbers start with 1. There are also our counting numbers. Whole numbers start with 0 because, and to help you remember this 0 or O in whole numbers, and integers are positive and negative whole numbers. Alright, some problems. I don't know if you've run into absolute value problems before. I think that you have. So really these first lessons before we get to class are all going to be review. But here we have an easy absolute value problem. It's the absolute value of -8. What absolute value means is the distance that a number is from 0. So if I draw really quick, and I never draw straight lines. I'm so sorry about that, but that's the way my lines look. So it's the distance a number is away from 0. So if here's 0, and here, if we went this way, 8 this way, and if we went 1, 2, 3, 4, 5, 6, 7, 8 this way, this number would be on -8. And the distance that number is from 0 is 8. Distance is always positive, and absolute value represents positive. So when we say instead of saying the absolute value of -8, we can say what is the distance -8 is from 0, and its distance is always positive, so your absolute value is always going to be positive. So the absolute value of -8 is +8. Absolute values are easy, just makes it positive. Okay, let's look down here at a little bit more complicated one. It's the negative absolute value of -15 plus 5. Absolute values are similar to parentheses. You do what's inside the absolute value before you do any type of distributing. So I'm just going to, even now I put most of my steps in. Some that you might want to skip, I put in. So absolute value would be negative absolute value of -15 plus 5. which would be negative 10, and your absolute value, whoops, yeah. And then the absolute value of negative 10 is positive 10, but you still have this negative sign out here, so we leave that out there. The absolute value of negative 10 is positive 10. So that's your final answer, negative 10. Hopefully that all made sense. Now we're going to add, algebraically they call it, positive and negative numbers. And they suggest you use a number line. I think this is the only lesson where they ask you to use a number line, just so you get an idea of what we're really doing here. So what they have you do is add, this is number 10, so 11 is probably similar to it. So they're saying add positive 3 plus negative 8. So you start with 0 and you go to positive 3. So here we go. We're going to go from 0 to positive 3. Again, I'm not good at these drawing straight lines with this pen thing that I have. So this takes us to 3. And then it says add negative 8. So we're going to start where we left off at 3. This is 3. I didn't really get there. And we're going to go from there and we're going to add a negative 8. So we're going to start here and we're going to go backwards 8. And 1, 2, 3, 4, 5, 6, 7, 8 leaves us on a negative 5. So I'm going to go here and I'm going to count backwards 8. Because it's a negative 8, so we would go to the left. And what we're going to end up with is right here on the negative 5, so your answer is negative 5. Now, I'm assuming most of you can do this in your head. 3 plus negative 8 is negative 5. You just add the two numbers. But the book does want you to show using a number line. So for these problems in this lesson, I want you to actually use a number line so you get a feel for what you're really doing. Let's try one more of these. Right over here, this one has more numbers, so it's a little bit more fun. You can call this fun. So let's just try this. Let's start with 0, and this first we're going to go to negative 4. So let me just do another color because it's kind of fun. So let's go to negative 4. It didn't switch. I still have white going on. Okay, and then from there, I'm going to add 2. So that means we go to the right 2. And then from here, we're going to the left, negative 1. So here we go. I'm going to run out of room. So we're going to go to the left, negative 1. So right now, it looks like we're on 1, 2, 3. It looks like we're on negative 3 right now. And then finally, we're going to add 5. So we're going to go to the right 5 places. So let's get another color for that. So we're going to go 1, 2, 3, 4, 5, and it looks like we're going to end up right here on 2. So we go 1, 2, 3, 4, 5. And where you end up is your answer, and so our answer is plus 2. So you can see we just went to the left 4, from there to the right 2, to the left 1, and then to the right 5. That's kind of a little bit fun. You could use colored pencils if you want to make it more exciting. Okay, the last problem I want to do is this one with unit multipliers. I don't know how you did unit multipliers when you did your pre-algebra, but I'm going to show you how we're going to do it in Algebra 1. So it's saying use 2 unit multipliers. You might not even know what a unit multiplier is. So a unit multiplier would be something like this. Like we know that 1 foot is equal to 12 inches. These are equivalencies. And what a unit multiplier is we're going to put one over top of the other and use it to multiply. So they call it a unit. These are units, and we're going to use them to multiply. So they want 2 unit multipliers, and we might have to do this in class depending on how comfortable you guys feel with these, because this is going to be all through Algebra 1, so we have to really get this down. So we're going to convert, we want to convert 42 centimeters into feet using unit multipliers. So even if you can do this in your head, I want you to use the unit multipliers, what I just showed you right here, to do conversions. A couple things you need to know is 1 inch equals 2.54 centimeters. You have to memorize that. And tomorrow I'm going to give you a couple more of these, a couple more things you have to memorize as well. So we need 2 unit multipliers. So what I do, as soon as I see that we need 2 of these things, I make 2 unit multiplier spots. So here's 1, there's 2. So we're going to need 2 of these fractional things to put in so that we end up with feet. So since we want to end up with feet, I'm going to just put feet right up here. That's what we want to end up with. So here's the tricky part. We have to go from centimeters to feet with 1 step in between. So we're going to use this one right here, that 1 inch equals 2.5 centimeters. Whatever is right here, we're going to put down here. So we're trying to go from metric system into English system. So we're going to have to use this one right here because it goes from metric to English. This is typically the one that we use to go from metric to English or English to metric. So we know that 1 inch, which we'll put up here, is the same as 2.54 centimeters. So what we made ourselves was a unit multiplier. There's always like a diagonal equivalency here. So these would cross out and we're starting to change. We're leaving centimeters and we're moving into the English system. So we need 1 more unit multiplier. We want to end up in feet. If we have inches up here, we need to put inches down here. And we know that there's 12 inches in 1 foot. And so here we go. The inches cross out. They should always be diagonal like this. And we write down what we have left. And they don't even multiply it out in this book yet until we can use a calculator. We're not using calculators yet in this class, but halfway through the book, or even less than halfway through, we're going to start using calculators. So we can just put down our answer, which would be 2.54 times 12, and all the units crossed out, and all we have is feet. So again, you can just leave it all like this. You don't have to multiply it all out, because without a calculator that it does not look like a fun problem. So that's how you use unit multipliers. We're going to be doing this a lot. So if you don't get this, please email me and we'll go over this. So I'm going to close this lesson now, and I'm going to give you another video on how I want your homework displayed. So that's it for lesson 5.